been a long week. I think I need to kick back.
Oh man, I'm gonna send that to you.
Oh, thank you.
So how's the semester go?
Oh, yeah, it's good.
Is it really?
Yeah.
Are you sure?
Really, I
can't just bring it back. So you see me, you Maggie the...
In this party, the room has a small volume, but there is also a small number of moles of people. So the pressure is low and everyone's enjoying themselves.
Molecule in the fourth dimension.
I missed my...
Running through...
25 people?
I'll go anyway, and no one can stop me.
In this party, the volume is still small, but the moles of people increase dramatically. This caused the pressure to really increase because the number of collisions have increased. Looks like this party is not going to go so well.
I came to dance, 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 dance. I hit the floor, cause that's my plans, 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 plans. I'm wearing all my favorite brands, 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 brands. Give me space for both my hands.
In this party setting, the moles of people are still increased, but the bigger room has a greater volume. So the pressure is dropped again because each person has their own space.
Hey, are you little copper and Twitter? Cause you are cute.
Thank you, that is so sweet.
What can I do to make them feel as bad as I do?
Man, it's so hot. Can you turn the temperature down?
If I turn up the temperature, the pressure will increase so much that they'll get in a fight and want to leave.
In this party setting, we see a change in temperature. This time the temperature increased, and everyone begins moving faster, causing the number of collisions to increase. This really makes the pressure rise.
I need a hot photon to excite my electrons. I got my eye on you.
But if I turn down the temperature, the pressure will decrease and they'll be just as uncomfortable.
This time when we see the temperature change, the temperature drops. Everyone has less energy and moves less quickly. Now the pressure is very low, and everyone is bored.
Hey, what's that?
The properties of an ideal gas are determined by the ideal gas law. PV equals nRT, where P is the pressure, V is the volume, N is the number of moles of gas, R is the gas law constant, and T is the temperature. By putting in different values, one can find an unknown property or use it to compare a gas in two different situations by rearranging what varies to one side and putting everything else that remains constant on the other side. For example, when the temperature of the room decreased while the volume and the number of moles remained constant, the pressure decreased. You can rearrange the ideal gas law to get P over T, the part that is changing, equals nR over V, the part that is held constant. Setting the two conditions equal to each other gives us P1 over T1 equals P2 over T2. Now just plug in the two temperatures and the initial pressure to find the final pressure.